I'm not seeing it advance. Maybe it's just me. I apologize.
Let's just check, Glade, that we haven't got a technical issue. And apologies for this because they're showing on my screen but not on the web link.
Okay.
Okay. I guess one of the challenges of us all having to do this remotely. So let's try share this again. Okay, I think we've got this working. Hopefully, everybody can see this. So we're on the title slide.
Okay, we see the opening slide there, Rob. We do have a comment from the chat. Oh, there we go. Okay, great. So we've already had our introduction, so we can move to the next one. Excellent. Well, you know, as we were preparing this slide deck, with the typical slide here would be something about who is Solvay, right? We could talk about, you know, all the different countries we operate in. I think it's something around 64 or 65, you know, something in the neighborhood of 25,000 individuals that we've been around for 150 years as Solvay. But as we had that conversation, we realized that it might be actually more telling as to who Solvay is by sharing this slide about Solar Impulse. We were one of the very first, or actually we were the first technical partner for the Solar Impulse project, the foundation. And again, this innovation, these new opportunities for us to participate in the world of sustainability, our conscientiousness about how our materials can change the way that we view transportation in the future are really what is core to our values and who Solvay really is. Like I said, what is our NDA? Or yeah, what is our DNA? Sorry. If we look at this particular project, there's something in the order of, I think it says 10 specific projects that are labeled as efficient solutions, but they believe there's over 15 products and 6,000 different parts of this aircraft were made with Solvay materials in its flight around the world. And so again, we could have talked about some of the financials, but this is really who Solvay is, and this is why we felt like this slide was much more important to share as opposed to some information about Solvay. Next slide, Rob. Now, as we look at, you know, again, a little more about who Solvay is, we look at, you know, we've been a participant in the aerospace industry for a half a century. Right, so we have the broadest portfolio and are a leader in the materials and process development in the industry of composites. We have materials of every different sort, every different size and shape. And our goal is not just to be a material supplier, but to understand our materials sufficiently well that we can to bring to our customers this a combination, again, not just of materials, but of the processes, of the expertise on how to use them, on design expertise that enable our customers to use them in the very most efficient way possible. And so that focus on what we call application engineering is really what we believe sets Solvay apart from the rest of the industry. And then lastly, you know, how do we really deploy that, not just on kind of a small scale, but how do we deploy those technologies that apply to mass industrialization? So again, as we look at where this particular market leads us, is that the volume, the number of parts that need to be manufactured, I think that this industrialization effort actually becomes particularly relevant. Go ahead. Next slide, Rob. As I mentioned in the previous discussion, you know, we've been supplying materials into the aerospace industry for half a century, for nearly 50 years. And so we have a strong legacy of materials for defense, for space, for commercial aerospace. It crosses the spectrum of all types of materials that need to be used in these applications. In addition to that, we actually have an equally strong portfolio of materials that apply to the automotive world. We have been supplying materials into motorsports, into cars, and now the latest generation of e-vehicles, e-mobility, with a portfolio of products that, again, we believe spans most of this industry, frankly. And we've been doing that for 40 or 50 years. So what do these two things have in common? Well, the very interesting thing about this is that as we look now to the future of what urban air mobility looks like, or this advanced air mobility market, we see that these two sets of industries, the aerospace and the automotive industry, and our expertise in each of these uniquely positions Solvay to be a supplier into this urban air mobility market. Again, so instead of making a handful of aircraft a month, we're talking about making hundreds of aircraft a month, or thousands a month. And so the ability for us to lean on our high rate capable materials and our automation ready products, and also the processes that we've developed to go along with those, in conjunction with our legacy materials, actually position Solvay to be uniquely qualified to supply this market. Next slide. I mentioned our diverse portfolio. Now, while today is specifically focused around just talking about MTM 45-1, we felt like it would be useful to make sure that the audience understands the breadth and depth of the broader Solvay portfolio in composite materials. So everything from just the typical thermoset prepregs to ones that are specifically used for compression molding, liquid molding, things that are used for vacuum bag only or other out-of-autoclave applications. Thermoplastics is a very strong marketplace, or material type that we deal with in the market. The advancements of low temperature curing paste adhesives, different film adhesives and surfacing film technologies like lightning strike or surface preparation that help, and these materials help to reduce the post-part manufacturing labor content. And then we also have a subset of our materials that also apply to injection molding, additive manufacturing, and then very specifically into the battery world, where many of our materials go into the construction of the batteries, different films, different binders and coatings, things of that nature. And so again, our product portfolio spans beyond just the products that we're going to talk about today. We just wanted to make that clear. So how does all this work together to benefit the urban air mobility development cycle? Well, first of all, we understand that there are specific materials, processes, and needs that are required during the prototyping phase. And this becomes particularly relevant in the choice of materials that you use, because ideally you can use materials in the prototyping phase and in the second phase, which would be your low rate manufacturing and certification, that actually are complementary or the same. That'd be an ideal circumstance. And the reason why that's ideal is because it helps to shorten the timeline that would be experienced in this process through this development cycle. From that point, from this low rate and certification phase, the ability to move into full rate manufacturing, and again, ideally using that same product, actually again, additionally shortens the development cycle. So this overall development cycle, and not just in time, but in material costs as well. Again, by focusing in on products that you can utilize today that help you achieve all three areas of manufacturing with a single product form brings great benefit to the industry. And so this is why we felt like that MTM 45-1 was uniquely qualified as a product that can be useful in the urban air mobility space. And so our focus is to make sure that we can support our customers through every single phase of this process: prototyping, initial production and certification, and also for right manufacturing. From here, I'll turn the time over to Rob to specifically talk about MTM 45-1.
Thanks, Glade. That's great. Thanks for the overview and setting the scene really well. And so I'll now spend a few minutes and walk you through a few slides that we've got focused on MTM 45-1 as a product, its attributes, why we think it's a good fit, and why we think it can really help advance the use of composites in this exciting emerging space of advanced air mobility. Now, it is important just to say that NTM 45-1 is just a part of our portfolio, so we do have a very broad portfolio, as Glade touched on, and he'll share a bit more of that towards the end of the presentation as well. But it's a system that we have in our products offering today that we think fits very well and will help in the early stages of this market evolution and development, while we also work on the future states and the future technologies that we think will be needed really when we think about the industrialization and rate challenges that are to come. So NTM 45-1 is a toughened epoxy system. It does offer a wide processing window, and with that suitability for many different design and manufacturing approaches, which is really one of the strong reasons that we are positioning it as a key product for this space. Now, it has several key features that we did want to highlight today. So one is it does carry with it aerospace pedigree. So that comes from its use in both primary and secondary type structures. It has vacuum bag only, so out of autoclave capability, as well as traditional autoclave fabrication capability. And it comes with product forms. It's an experience that is very applicable to standard hand layup, but also product forms that are very suited to automated fabrication techniques as well. So as you've heard me mention, it does have really good process flexibility from certainly from an aerospace pedigree perspective. So what this means is beyond the this out of autoclave capability, it also has very good cure flexibility in terms of the capability with the system. So it does cure down at 80 degrees Celsius, which for early stage prototyping, when maybe there's a higher frequency of change to design, with that a higher frequency to modify the tooling, this can have some really good benefits in terms of lowering the cost of the tooling, lowering the cost of change, and really enabling our customers to work in a rapid and agile manner with this system in those early stages when there's a lot of optimization and exploration work that's going on. Now, having said that, it also has high temperature cure capability. So as with a lot of traditional aerospace systems, it does cure up at 180 Celsius to get its full performance. And this really delivers a very capable level of wet glass transition temperature performance up at 160 degrees Celsius. So really, very high capability from that perspective, and is a homogeneously toughened system. So drives with it a good level of aerospace performance from that standpoint as well. In terms of the data and the data availability that we have, as you'll see, we do have extensive data available on this particular product and the portfolio that goes with that product. And what's very critical with that is that data is both accredited and verified through the NCAMP Institute and process. So really, another strong attribute of this system, allowing our customers to not just work very effectively with its capability, but also to take it to market as quickly as possible through the design and qualification approach that's needed. And of course, with many of our products, we have a broad selection of product forms that are available. So we do view it having a nice suite of product forms that our customers can choose. And again, I'll touch on the details there, but really sets the system up well for the different approaches that we're seeing our customers having interest to take. So overall, a system that really helps lower qualification costs and time because of the databases and the product forms with that data that we have. A very reliable and robust level of performance, as you'd expect from a legacy aerospace system, but coupled with this process flexibility that really allows our customers to work in a very effective and efficient manner. Again, certainly as they're looking at the early stage development, but having that system then carry all the way through to initial low rate production and full rate production. So allowing the material to have a common thread as you go through the different phases of development. And for that, we do think it's a system with a very good aerospace pedigree. With that, it brings a really strong database. It has fantastic process flexibility and a product family that really should enable the rapid adoption and time to market for our customers looking to operate in this space. So when we talk about its aerospace legacy, and it does have proven legacy and demanding applications, I've just got some examples here, and I'll talk around the X55 program in a bit more detail on a dedicated slide. But certainly in the defence space, the NTM 45-1 system was used in Lockheed Martin's X55 program, so the Advanced Composites Cargo Aircraft Initiative as part of the Composites Affordability Initiative. And the system here really, was used to take advantage of its out of autoclave capability, used in very large, complex structures, and really enabling the customer and the project really to take advantage of that with the philosophy that they took. And again, I'll talk around some of the benefits that helped deliver in a few moments' time. It's also a system that's got some legacy and history in the field of space. So it's certainly used by Virgin Galactic with the Unity and Eve airframes. And here, 45-1 was really utilised for the majority of primary structures, again, for large, complex components. And here, the real value that was maximised from this is this ability for the low temperature cure, and for the ability that allowed for design changes and optimisation early in the process, and to help lower the cost of the development phase for the program while maintaining that high level of performance that the system offered. And then it is a system that's used in commercial aviation as well, so used on programs where it has FAA certification, used in damage tolerant designs, providing that in-service validation of the performance, and again used on a variety of approaches with some complex sandwich and monolithic components that are utilised. So just to focus on the X55 case study in a little bit more detail, and part of the reason for this is, one, I think it really helps showcase and demonstrate 45-1 as a system in its own right for a very demanding project and demonstration of the use of composites. I think it's also a really good example of the value of using composites for lightweighting complex airframe architecture, and how those benefits can really be realised in terms of the manufacturing, the performance, and the cost perspective when you look at the total cost of ownership and the holistic view of how the choice of materials and process can impact the overall cost structure and performance from a program perspective. So 45-1 was used in this initiative, and this was a research platform. I think the first flight was back in 2009 on this, where a Dornier 328 baseline aircraft was taken and modified for the inclusion of composite materials, but really with a view of bringing two aspects to it. One, can composites be demonstrated for both the design and manufacturing of an aircraft, both at a quicker rate, at a lower cost, and at a higher performance. And with this, the vacuum bag only capability of 45-1 was used, but also with a philosophy of bonded assembly. So a very interesting project for those of you who are not familiar with it. So I recommend taking a deeper look at this for the demonstration of what you can achieve with bonded assembly, and really using composites as they're intended to be used, and really capturing that benefit. And some of that you can see here, that overall, when you look at the schematic, the only parts that were retained in metallic were the forward cabin, the wing box, the horizontal stabilizer on the rudder. The rest really taking advantage of composites and really driving the demonstration that they could reduce the overall part count from initially 3,000 metallic components down to 300 structural parts using a composite design, and with that really eliminating the amount of mechanical fasteners that were used. As you can see here, quite a significant reduction there in terms of the mechanical fastener assembly that's more traditionally used. So for us, a great case study for the material, and a great example of what 45-1 and composites can offer. Now, as I said, 45-1 does have a process flexibility that really does enable a very good level of versatility and scalability from its use case perspective. Now, what this means is, again, I referenced this earlier, but with the lower temperature cure capability the system has, and it does process well with vacuum only capability, it does allow our customers to have, let's say, lower prototyping tooling costs. So again, when you're in a phase of a high frequency of change. Because we've got that lower temperature, it means you can look at maybe additive manufacturing type tooling approaches where you need to keep maybe at a lower temperature range or a lower performance range, but because the material can adapt to those capabilities, it does enable some interesting options from a rapid prototyping perspective. It's also, as part of our data set, we have the ability to work very closely with our customers to help simulate the processes and really optimize the processes based on the kinetics and the behavior of the resin through that. So we do have full Raven models for the convergent software with MCM 45-1 that really allow us to work closely with our customers as part of the process development and process optimization perspective. And with that, again, it has this cure flexibility across a variety of different temperatures and times, both with vacuum bag only capability and autoclave capability. So when we do look at the needs across the different cycles of program development, all the way from prototyping to certification, low rate initial production and full rate production, this broad capability that the system has really allows us to keep the same material throughout the cycle, but really work with our customers to optimize the process depending on the needs that the program drives at the time. Now, as we said, we do have a very strong data set with this product as well, and we're not now going to go into a lot of slides with data. We do have a short summary that I'll share with you next, but just to put your minds at ease there, we won't be going through a lot of numbers, but certainly encourage people to reach out to myself or Glade, and we can set up conversations if there's interest to talk through the details of the data that we have. But we do have an extensive data set with this system, and that's really full laminar suite of properties across different environmental conditions, as you'd maybe typically expect with a qualification type database. One of the really unique things we do have, though, is an extended laminate data set with this system as well. So across typical design properties, not just with quasi-isotropic type layups, but also with soft and hard layups, really to give that extra level of detail in terms of how the system performs as you get into some of the design criteria that you may have. Now, with that, of course, we have validation of the fluid sensitivity type properties that you'd expect to see as well as a series of bearing bypass type properties. So very good, very strong data set that we've got. And of course, that is accredited and validated with the NCAMP Institute as well. So, really an excellent level of data that we've got that really allows you and as our customers to work with this system and really have an accelerated view of how you can start designing and working with the material, but also have it ready to be validated through the typical qualification and certification requirements that are needed. And we do believe that this does help this system position itself with that process flexibility as a system that our customers who have a strong need to be very fast to market and shorten that cycle time to market, a system that can help people take their programs from concept through to market insertion in the fastest time possible. Now, this is just a snapshot of the data that I mentioned, but just really to reference, we have some of these design type data across different types of layups and configurations, and just really to highlight here that the system does have a good level of compression after impact and damage tolerance, as you'd expect from a typical aerospace system. It has a reasonable level of notch compression performance, and as you see from the wet TG, a really good level of service temperature capability. And again, the full database that we've got is really there to help our customers work with this system in an accelerated fashion. So please do follow up with us after this webinar for questions or inquiries, and we'd be more than happy for our engineering team to work with you on your interest and needs from that perspective. So, of course, we've spoken about the capabilities a bit, the performance levels a little bit. It's more than just the matrix and the fiber, of course, and with that we do have a portfolio of product forms with this particular resin system. So within the core part of the portfolio, and here to really the foundation of the portfolio, we have our structural product forms, so our 45-1 pre-preg product forms. The ones highlighted here in blue are the ones where we do have NCAMP data sets available for them. We are also working on some new product forms with the resin system. So this is a list that we're looking at really making sure we tune the portfolio to the needs of the urban air mobility or advanced air mobility space as that emerges. Now, as you can see here, we have a variety of unidirectional and woven architectures covering both intermediate modulus fibers and standard modulus fibers. So, really quite a good complementary perspective in the base portfolio that we do believe covers a lot of the needs of our customers in this space, and particularly with the aerial weights that we've got here, really is tuned to helping our customers design for thin gauge and weight optimized structures, which we do see as being a critical part of this emerging space. So we do have, as you can see here, some glass fiber product forms as well, covering both E, S2 and quartz type fibers. And then of course we're aware that the pre-preg material is only part of it, and we do have a full suite of complementary products as well with our market leading position from our adhesives and surfacing capability. So a full suite of adhesive films and pastes that work very well with this product form and are fully compatible, as well as surfacing films and lightning strike protection, really to enable us to provide the full portfolio of product form needs that we see our customers needing to really look at advanced and complex airframe structures in this space. So with that, hopefully that's given you an interesting and insightful overview of the product itself, but I will hand back to Glade so that he can talk you through the remaining slides that we've got.
Thanks, Rob. As Rob noted, we do have, and I mentioned earlier, we do have a broad portfolio, and MTM45-1, though, is the focus of this conversation. We did want to spend just a moment to highlight the other materials that are also very capable in this space. We won't go into the details of these particular systems, but we just want to make sure that you're aware. We have a handful of other products that we specifically believe are very applicable for UAM. And of course, it goes beyond these as well. The list that you see here is some of our thermoset materials. And on the next slide, you will see a list of some of the thermoplastics that we also believe will be relevant. Again, as we look to the future, we see that rate may dictate in some cases that thermoplastics are very interesting as well. Go ahead, next slide, Rob. I'll go ahead and click that again. Looks like the animation is a little mixed up. Okay, there we go. As we think about the future and what does the future bring for the evolving market needs that we have here, we are really keenly focused on being innovative in this space. What does that really mean? So we will continue to focus on the advancement of thermoplastic materials, again, to make sure that as people have requirements for thermoplastics, either for their performance characteristics or for rate requirements, that those materials are available. We have specific projects ongoing right now to address the needs of battery storage with composite materials. These FST systems, these fire, smoke, and toxicity systems, capable systems, are particularly designed around the very difficult requirements of flame impingements, things of that nature, that at very high temperatures, and making sure that the occupants of these aircraft are very safe from any potential issues with the batteries that are there. Also, to be noted, we are working constantly on introducing new NCAMP data sets. So the information that Rob mentioned earlier in relation to the NCAMP's material, the data that's available for MTM45-1, we have data sets available also for some of the other materials that you saw on the previous list that we showed for thermosets, and that will they'll be matured, right? So there'll be other product forms introduced, new resin systems with new NCAMP data sets as well. And then really our objective is, as we continue to understand the material needs of this market, we are introducing new high performance materials, faster cure times, where required, lower aerial weights to provide the best value to performance balance possible to the industry. And of course, with the overall objective being reduced total overall costs. And then as we look at how we best interface with our customers, we have actually two different material and process application centers. One that's based in Belgium that's focused on thermoset composites. and the other that's based in the UK, that's based on thermosets. So, what do we do at these application centers? There's a high focus on our ability to provide support for virtual engineering. We actually have the capabilities to work in conjunction and collaboration with our partners and customers on manufacturing parts in these higher rate capable manufacturing processes. So we have things like double diaphragm forming, injection molding and overmolding processes. We have, again, just compression molding lines, things that actually that we can demonstrate capabilities so we can help to offset some of or share or offset some of the costs that our customers have, and not just development of the materials, but in the development of the processes and how those processes can then be deployed back down to your tiers or you as a customer to manufacture parts. And then, of course, we also have, tremendous testing capabilities in terms of what we can offer to help support our customers' requirements. So again, the long-term objective is how, again, going back to some of our initial slides, how do we help to both innovate and industrialize the use of composites as we see this industry maturing. Now, to come back and answer the question that we started with, right? That there's a dilemma of sorts in the selection of materials. And while there are lots of materials that would be available in this space, we wanted to highlight, again, as we close this conversation, as to why MTM 45-1 we believe is uniquely qualified to be something that you should take a serious look at. Again, Solvay is one of the leading aerospace composite material suppliers. We're innovative. We're looking at new ways of making materials and making processes that will help deliver solutions. The ability to use, in this case, particularly MTM 45-1 to be cost efficient, to leverage all the learnings that we have from our automotive experience in the past. And then as we look specifically at 45-1, it can be used for everything between this prototyping all the way through the commercialization. And that includes the variations in manufacturing rates, the ability to prototype with it, as I noted. And really, this product is actually supply chain ready today. We have all this mechanical data that's available through NCAP, and it really can shorten your development time. And then lastly, our focus really is on being a collaborative partner with the industry. How do we best bring our material and not just hand it off to you and say, here, good luck, but to actually work with you to bring our expertise and knowledge about this process, the materials to bear in order to shorten your development cycle. All right. Thank you, everybody. And with that, we'll turn time back over to Ginger.
Thanks, Glade. Thanks to both of you. That was a great presentation. We do have questions, so we'll get started with those. In the meantime, those of you who have questions, please enter them. If we don't get to everything while we're on the air, this webinar is being recorded and will be available online, and we will get answers to your questions to you after the event. So we're going to start with, are people using this as a two-stage cure to speed up tool turn time? So in other words, you finish the cure off the tooling.
Yes. Sorry, maybe a question for you, Ginger. That it is with the capability that the system has, depending on obviously the size of the structure and the design approach. It does have the capability for a two-step cure approach, but again, an area that's certainly we're ready and welcoming to work with our customers to explore. Okay.
What is the difference in voids when you cure MTM 45-1 in an autoclave versus vacuum bag only?
Yeah, very good question, and one that we I think is quite often asked when we talk about vacuum bag only. I'd say we certainly I certainly want to avoid saying that you end up with void-free laminates from processing, as I think all of us know who are very close to the challenges of composites. That's one of the real real challenges, especially when you get into low pressure environments. What I would say is that we do see equivalent, let's say, aerospace capability. So in terms of when we certainly see, maybe typical specifications coming out less than 2% voiding, again, with the right approach to process development design and tooling development and design, the system's very capable to meet that comparable level of performance with vacuum bag only processing.
Have you tested MTM 45-1 on compression molding applications?
Yes, that's an area that we are looking at in detail. So we do have a lot of focus on compression molding within Solvay. With the application centers that Glade mentioned, we have a lot of capability around double diaphragm forming and technologies associated with that we've worked on developing a lot, and this is a system that we're exploring in that space. Absolutely.
What is the fastest cure cycle covered by the qualified data set? I'm assuming that refers to NCAMP. Can the cycle be made to go faster while retaining confidence in that data set?
So yeah, the NCAMP data sets do relate to the specific cure cycles that we have validated that data on. There are cure cycles outside of that the system is capable to. So I would certainly say it's a case where we need to work closely with our customers to understand what's needed from that prototyping phase, where maybe some lower temperature cycles are needed, versus how we then get to the NCAMP database for full production and certification, or looking at generating that data, which would be another viable path. The fastest cure cycle that's covered at the moment, depending on the product forms, certainly our base cycle is an initial, I think, 3-hour 250F cure followed by a 2-hour 350F cure. But certainly I'd recommend maybe a follow-up discussion on that, just to make sure we can get the right data and details to you on the specific cure cycle and process you have in mind.
Hey, Rob, it might be worth noting that we have done some, though it's not been done through NCAMP to this point, but we have done some equivalency data generation for some of our other aerospace systems in rapid curing environments, such as in a press. I'm not sure if you want to comment on that specifically or not, but I think there's some relevance there.
Yeah, absolutely. Absolutely.
And I think, go ahead.
Go ahead.
I was going to say, I think that it is notable that there is a plan, as Rob noted, to do compression molding. So in a press with MTM 45-1, we're working on that. But we have actually generated data on, again, other aerospace systems in a press, just to be very clear, right? So that we have these rapid cure cycles, some of them down as low as 30 minutes. Again, I'm not specifically suggesting that MTM 45-1 could be cured in 30 minutes in a press, but we have generated data that shows in some of our other aerospace systems that we can get equivalent mechanical properties, or again, whatever equivalent means, a family population of material properties that actually is equivalent.
Rob, you did pressing in the wrap-on project, right?
Yes, we did indeed. We actually did the wrap-on project was really around kind of what we touched on a little bit in the presentation, on bringing this automotive philosophy for high rate production with aerospace performance capability. So that project really helped show and demonstrate how some of our aerospace systems work with compression molding, and with that we have a lot of knowledge and capability around what that means from the material and process standpoint.
So for the webinar attendees, I wrote about that and pretty extensively. So you can go onto our site and Google RAPM, and you can find more of what they did there, and with Boeing and with the DoD. How does surface finish vary across product forms? Are there any better than others, and why?
Yes. So yeah, certainly different product forms will give a different surface finish. And I'm maybe commenting here more from the automotive perspective, where we know with the work we've done there, certainly around looking at maybe more body panel type applications, where you really want to get a very good Class A surface finish, and how the surface, even once painted, will reflect the light differently depending on, again, the design and the architecture and the fiber that is used. So again, not quite clear there in terms of the surface finish reference that's been made, but certainly the selection of the product form will influence the surface finish if you're thinking about the aesthetic side of things. And then from a, let's say, more from a structures perspective, and certainly relating more to formability and capability and influence or propensity for wrinkles, again, we know very well that different product forms will have different levels of forming capability from that perspective. But again, we have the expertise and knowledge within the team to work with our customers to help navigate that with the options that we have.
For the wet TG, how do you measure that, and what standard are you using?
Yeah, so the typically the wet TG so certainly will have been to moisture saturation and will have been generated through DMA analysis. But again, we can share with the data that we've got. We can share curves and the methods and everything that's from there. And we've likely used a variety of different methods as well, whether we're working with European-based customers or US-based customers, depending on the standards that are referenced.
What is the tackiness level of MTM 45-1, and can the tack levels be adjusted to fit different manufacturing processes?
Yes, to some extent, and usually you'll find that the tack level for hand layout will be maybe different to that of an automated product form, and again influenced by some of the parameters that we can tune and optimize within our production process. So there are, let's say that there is the ability to tune to a certain extent, because some of it is governed by the chemistry and the product itself. And of course, for products that are qualified within a database, those production parameters are fixed for that particular product, but quite typically are optimized and tuned during the development process for the intended use.
What percent porosity do you typically see in OOA processing?
Yeah, so I guess relating back to the earlier question that we had, so we'd certainly say when we develop systems for out of autoclave processing, we certainly in this case talking about having equivalent performance in the final composite between the VBO system and the autoclave system. Of course, I would put some parenthesis around that as we all know, the design and the manufacturing approach ultimately influences what you get in the final component. So because of the many different factors, it does depend on a application to application basis. But certainly from a, let's say from a base fundamental material level, the system does has the capability for equivalent levels of quality.
When you switch from an 80-degree C cure to 180-degree C, do you see a difference in mechanical properties, room tip and hot wet?
Yeah, so for the lower temperature cure versus the 180 cure, we wouldn't necessarily expect equivalence in terms of performance, which is why we do see a lot of value of that low temperature cure for the prototyping phase and really understanding how the material behaves with relation to the design and approach that's been taken. But certainly if to get the full benefit of the system in terms of its performance capability, you would really want to look at how do you then bridge that to the full temperature cure cycle as your project or your program evolves.
Hey Rob, I guess you would assume that after that ADC initial cure that you would post cure it. Is that just to be clear, right?
Yeah, absolutely. Yeah, yes. Thanks, Clyde.
Yeah, so cure to ADC would definitely not be same as 180C, but you would get the closest set of mechanical data as if you do the post cure after the ADC initial cure.
Does NTM 45-1 have fire retardant capabilities?
It's from a so it's not an inherently it's not designed or developed inherently for fire retardant. Whether this is a question around the typical FST performance of systems for, let's say, interior or fuselage type applications, we would need to check what data we've got. But again, that's one that certainly I'd be happy to follow up on after this session for a more detailed discussion.
What is the quality of the composite parts out of the autoclave? Do they need to be pre-treated before applying decorative coatings?
I'm not sure I follow that question, sorry.
So do you have to do any kind of surface treatment after autoclave?
Yeah, I mean, I guess it depends on what the decorative coating would be. We do have our Surface Master 905 surfacing film that's fully compatible with the system that does, give a very smooth and consistent finish to the composite that's then ready to go through to priming and painting.
Okay. Is MTM 45-1 compatible with the squirtum process? So that's the RTM process where you use pre-preg, but then you inject in. And,
yeah.
And what resin would you use for the injection?
Yeah, it's a good question. It's an intriguing process that we see a lot from, and one I think has some interesting attributes. Certainly when we talk about rate and dimensional compliance of complex components. We personally haven't done much testing with this system, with the squirtum process. I think we'd be open to a discussion around the interest there and what the project may be, and helping answer some questions on how suitable it would be. Given it's a homogeneously toughened system, it would be in the class of systems that I think we'd be comfortable exploring in, because we know that those systems typically work quite well with that process. In terms of what resin would we use for the injection process, typically we would focus on using the same parent resin with that. So we'd need to look at the flow characteristics for the process window that was in mind for the components. But certainly one we'd be interested to have more discussion on.
Where do you see the application of thermoplastics in urban air mobility, specifically thermoplastic sandwich materials?
It's a good question. I think I'm just glad you touched on with the breadth of portfolio we've got. I think thermoplastics have a lot of potential and a lot of attraction for this space. Certainly when we talk about the rate challenges, I personally think we will end up seeing that both thermosets and thermoplastics have a part to play in the UAM space. Certainly from a rate capability perspective, and certainly if things like welded assembly can be proven out and certified, because that could really bring, I think, thermoplastics into an interesting space. Thermoplastic sandwich construction in terms of thermoplastic core with thermoplastic skins, I think that is an area that for the market in general does need more development, and an area that we have some activities in. But again, one that would certainly welcome some further discussion if there's a strong interest in that area. Glade, I don't know if there's anything you want to add on that in terms of the overall market perspective of materials.
No, I think you covered that pretty well, Rob. Thanks.
It was mentioned that there are FST systems for battery enclosures. Are FST requirements from aviation, does that go across into UAM? I would imagine, we'll know by the end of this year, but I would imagine for the interiors, yes, yeah.
I agree. I think we'll all find out soon. I think we'd certainly expect it to be, given given the type certification that's been targeted for this space. In terms of the battery enclosures, I think we do see this as an emerging area of, let's say, exploration and knowledge gain for the market in general, in terms of there's a lot of work needed for the battery structures for the space, but also what does that mean from a material performance and capability perspective. And again, an area that we're very interested to work with partners and customers on. So if this is an area where people are looking for project partners, we'd certainly welcome further discussion after this.
So one question was, can you define the dilemma, quote unquote, as you see it? You guys mentioned the dilemma in your title, obviously. I mean, in my mind, there are a lot of dilemmas for UAM. It's rate, it's qualification. There's a lot of issues.
Yeah, I can give my view, and then Glade, I'll hand it over to you just so people
Sure.
get a chance to hear your voice a little bit as well. But I'd say, we certainly see this is a really exciting emerging market space within the aerospace industry, and certainly within the composites industry, we see there's a lot of drive for certain customers and companies to get a first in position, and a lot of challenges with that. And because of that time frame, I think there is this this element of what material systems have the data available and that are ready to go today in terms of helping build these advanced structures, and with the reliability and the robustness that's needed to go through certification and qualification and certification. I think that there is a question with that though around, if we look at how composite materials are used today, certainly a lot of the high demanding applications, that the rates are not really where we're seeing the projections be for the UAM or AAM space. And that's where part of this dilemma comes in around, how do we all working in this space, in this emerging part of the industry, collaborate to help prove the art of the possible and make this happen, but with a view of how do we then address the challenges that are coming around. If this is going to be as successful as we all hope it is, how do you help get to rates, and how do we help composite materials be used at the rates that are going to be needed, that are being projected? Because it's one challenge to use composites on structures as they are today at a few tens of vehicles per month, but if you really get into hundreds of vehicles and the performance levels are the same, that's really one of the technical and industrialization dilemmas I think we see.
I would agree with that. I think the biggest part of that dilemma is how material leads to industrialization. Right? Again, as Rob noted, from low to certification to full scale manufacturing, and being able to select materials that position you the best in that space. And I think that's the big question, and I think that's the thing that we've tried to focus on in this conversation, is how MTM 45-1 can be one of those solutions. Again, there's other products within the Solvay portfolio that can also meet those challenges. We just felt this was the one that was most appropriate to talk about today.
I have an interesting question here. Do you see material properties as equivalent between OOA and press cure?
That's good question. So with this particular system, we haven't demonstrated equivalence today, certainly when we talk about NCAMP, but certainly the work we've done with press cure systems, and again the reference to the RAPM project is a great reference point for people to look at, or we can certainly follow up afterwards, where we have demonstrated some really good equivalence between autoclave and press cure. There are some nuances to it, certainly around if you take a existing qualified system and try to put it in the press, depending on the cure kinetics and the flow kinetics, making sure there's a balance on the final pair ply thickness or cure ply thickness between the two routes is one thing that needs to be looked at, and the system really needs to be tuned to that. But again, we have some really good experience and strong expertise in that space to help our customers look at how you can take a system and use a multitude of different approaches to get to the airframe or structure that you need, and take advantage of maybe reducing the number of materials that are needed to be qualified for them.
I'm going to do one more question. It was mentioned that MTM45 can be cured as low as ADC. Does this mean that it gels at ADC? And if so, how long does that take?
Yes. So the first answer is yes. It can be cured at 80 degrees C, and to Glade kindly you do obviously need a post-cure to 180 to get the full temperature capability. The overall cycle at 80 is long, because the system has that high temperature, low temperature capability. So for the details of that, I would recommend reaching out to us. I believe, if my memory serves me correctly, I think this overall cycle time was 18 hours at 80 Celsius. But again, please follow up so we can give you the correct details on that in a direct discussion.
Yeah, that sounds correct, Rob. The other thing that, just to point out, I think you mentioned it earlier, is that low temperature cure enables you to use lower cost tooling. Again, specifically to prototyping, that becomes very useful.
All right, well, thanks again to Glade Gunther and Rob Blackburn and to Solvay for this webinar. We invite all of you to reach out to these experts to learn more about the whole portfolio of materials for UAM. We also want to thank our attendees. We appreciate your participation, and we hope to see you again soon at the next Composites World webinar. Have a great day, everybody.